Hey everyone, this is Elijah here with Elijah Analytics, where we go over data projects, industry trends, and help you land your analytics job. So if this is something you're interested in and want to get along for the ride, then feel free and let's get started. So in today's video, one of the things I'm interested in is basketball analytics. And in basketball, I'm not sure how many of you are familiar, there is the shot frequency of how often people can shoot from different areas on the court. So I was curious, what's the best place for people to be on the court to maximize where they're comfortable shooting from, and then mixing that with people that shoot from different areas to then have a very cohesive lineup. And today, what I'm going to try to do for that is displaying a court and then having each person's shot chart data on that court to then have that to be further analyzed. And for that, of course, we need the data first. And so the data that we'll be using is from a package called NBA API. To go to NBA API, you can go to the GitHub page here, and it has data on any type of NBA data you can think of. It has game data, it has different data from different seasons, as well as ones with shot charts. And the installation for this is to run pip install NBA API. So if you go to the documentation here, this is the code that you use to install it into your machine. And I already have it in my machine, so it won't show anything if I run pip install NBA API like this. So I already have it, and I will just clear this. So that is installed, and then you have to import shot chart detail, which includes the shot chart data, as well as a list of the players. So from NBA stats, NBA APIs.stats .static, you import players, and then we'll be also needing pandas and the time package for this project. Now pandas is a very common package for data science applications because you're able to store data as data frames, and you can do a lot of transformations on it from there, like exporting it to CSVs or Excel files, and also can do things like renaming columns or applying different functions to the rows within the columns. And a time package is so we can section out when we're adding people to our list of active players that we're getting data for. So first, what we need to do is get a list of all the active NBA players. And for that, we can use this players method from the NBA API.stats.static package. And then it has a method called getActivePlayers. And this will get a list of all the active NBA players. And then what we'll do is then we'll create an empty data frame here called allshotsdf, and this allshotsdf we will be appending all of the NBA players to along with their respective data. So now what we're going to do is in that NBA players list we're going to go through each player in that list, and then we're going to get their player ID and player full name. And this is how we're going to be able to get each person's data. So we're going to use this try command to say that if we're able to find a player in the NBA players list, we will go to this next step, which is calling a shot chart detail method for each player. And so this shot chart detail method, it has parameters that you have to abide by. And the first one is the team ID, and the team ID equal to 0 means that you're searching through all teams. And then your player ID is equal to the player that we're looking for. And then the season type all-star, that is saying that we want just data from the regular season. And for this case, we'll just be using data from 2023 to 2024. So that's why we'll set season nullable equal to that. And then finally, we're putting context measure simple equal to FGA, meaning that we're just getting the field goal attempts. And then from that data that we're getting, we then go to shot chart. And then from there, to get the specific name of the player, we have it stored at the top. So then we can create a new column that says the shot chart data player name is equal to the name that we have. And from there, what we'll do is we create a variable called allshotsDataFrame, and then we're doing pd.concat allshotsDataFrame shot chart data. So that's saying from our initial allshotsDataFrame that we create, we're adding on the shot chart data of that specific player that we're looking for. And then after that's finished, it will say print, and then whatever player we're on, it will say that person is added onto our data frame. And for here, we just use the time.sleep function, and we set it to 1 second just to avoid hitting API limits, because if you hit it too frequently, sometimes it can error out for you, and that can cause a delay. And we'll end it with an exception and saying that if this is not true, so then we will print we could not get data for a specific player, and it will just specify with the player that we're currently on. And if we run this, then you can see that it's running, and then it will go through each person in the NBA, and it will say when they're added on to our data frame. And I'll be back when this finishes running. Okay, it looks like everyone from the NBA is uploaded into our all shots data frame. So if we run this here, we can see that the letters from A all the way to Z of players are uploaded with 430,000 rows. And we have things like the ID, the team name, the period and minutes remaining that the shot was shot at, along with the seconds remaining, and then the range, and also the coordinates, which we will be definitely using to plot our shot chart. And then as well as the home team and away team. So this is good information. It seems like now we have everything that we need to create our shot chart, and then what we'll do is we will export this data frame to a CSV, and we will call this all shots data frame 2023 to 2024. What we'll now do is make a separate Python file to create our web app. To create this web app, we will use a platform called Streamlit. And Streamlit is a way to create web apps primarily for data science projects. If you go to Streamlit's website, you can see that they have examples of things you can make with their applications. They have a gallery of what people have already created in the community. So you can see they've made all types of different charts and graphs, but today we'll be keeping it fairly simple, and we'll just be creating a shot chart of the data that we've created with the NBA players. We'll be using Streamlit, but we'll also be using Matplotlib to create some of the visualizations, and then MPL basketball and the court method within there to create our court, and then plot the shot charts onto there, and as well as using pandas again. So what we'll do is we'll create a title for our web app called NBA Shot Charts, and then underneath it we have a subheader saying to filter on any team and player to get their shot chart data. And then we'll read in the CSV file they created by using dataframe equals pd.readCSV. And then when we go to the location X and Y coordinates, it's not easy to tell here, but if you go to the documentation on the NBA API on GitHub, it shows that the data is in inches and not feet. And our court is going to be displayed in feet. So what we have to do is we have to scale our coordinates to match feet. And to do that, we have to divide it by 12. And now that converts to feet. And then also, there's different courts that you can create within the court package of MPL basketball. There's a couple, there's like vertical, there's horizontal. And for this one, we use the vertical VU court, which is saying vertical upper. So the basket is on the top, and then the half court is on the bottom. And with having this style of court, we have to have the location X and Y coordinates to match on those correctly. And to do that, we scaled the location X by 1.2, and then we added 39 onto location Y, as well as flipping them by creating a negative sign. Now what we'll do is we have a team names variable that we will have as the data frame team name. So we're just getting all of the team names from that team name section. Now what we'll do is in Streamlit, we'll create a select box telling the user to select a team. And to get the team names, we'll use dataframe.teamName and then .loc. And this section here is to have the team name sorted by the team name and not by the city name. Because, for example, I want to have the Philadelphia 76ers appear first, and then the Milwaukee Bucks after that, then the Bulls third, and so on. I don't want to have the city names sorted first. So to do that, what we're doing is we're going through that team names variable that we said and then applying a lambda function. So this lambda function will apply this condition to every row within the team name section. And so it's saying for each team name in our team names list, you're splitting it based off of the city. So we're splitting up Philadelphia and 76ers, and this -1 is getting the reverse first. So in the reverse would be 76ers, and then same thing with like Milwaukee Bucks. It will split up the names Milwaukee and Bucks, and then it will just get Bucks and then have that to be sorted by. But there was a use case I had to account for, which is with the Portland Trailblazers, because they're a unique case where if you sort by the last name first, it only goes by Blazer, but you're supposed to be sorting by Trailblazers because that's part of their team name. So I said that I would use this function only if it's not equal to Portland Trailblazers, but if not, then I'll split on the T, which is 1 in this case. And then down here, you're sorting those values by the team names, and then .index saying that's the index that the teams will appear in. And then finally, you will get a .unique, so just returning the unique instances of each team. Then we're creating another select box called player. We prompt the user to select a player, and then from the data frame team name equal to the team that's specified, we will get all the players from there and then the unique cases of them using .unique, and then index equal to none, meaning that we don't want people to show up before the team is selected. So only after the first team of like 76ers is displayed, then that associated list of players will then appear. Then down here, we define a function called filter data, which takes in the parameters data frame, team, and player. And then it says that if a team is selected, then the data frame will be a data frame of where the team name is equal to the prompted team. And then same with player. Once a player is selected, then the data frame will be a data frame of the player name equal to that player. And then we'll draw a court using the court class here. And we'll say the court type equal to NBA, center origin, the units are in feet, and then figure axis equal to court draw orientation equal to VU, saying that these are the figures and axis that we'll use for our court. After that, we'll create a function called plot shots, where we take in the coordinates of data frame, axis, and court, and we're plotting the heat map using our hex bin here. And we're using the axis that we created, and then we're saying ax.hexbin, and then the coordinates of the shot that we're looking at, so data frame location X, location Y, the grid size, and then CMAP equal to Civitas, meaning that this is the color of the heat map that we'll be using. And then Z order equal to 0. This is to ensure that on our court, the lines aren't being overlaid by the colors. So all of the 3-point lines, the base lines, everything is being put to the forefront, and then the colors aren't overshadowing them. And then extent, this is just to extend the colors out so they go past the court, so it seems more cohesive. Then we're using matplotlib to create a color bar on the side, which is creating color bar of the hex bin with the axis equal to the axis created, and then creating a label called shot frequency. Then finally, we call the plot shots with the data frame axis and court created. And then finally, we're creating another Streamlit pyplot.fig. And then finally, we create a Streamlit pyplot to plot our court using the figure function. Then finally, we're using Streamlit.pyplot to create a figure with the court that we created. Then finally, we're returning the data frame. Then down here, what we're doing is we're creating a filter data frame and equaling it to that filter data function that we have, with taking in the parameters of data frame, team, and player. Once you save this, then you want to run Streamlit, run, and then you want to specify the file name of the file you're using. So NBA shot chart.py. Then it takes you to a local version of the Streamlit app that you just created. So this is not available to anyone. It's just available on your local computer. You have to deploy it to Streamlit's website to make it accessible to everyone. But just for a local example, you can run that command and you can see it for yourself. And here you can see you have the NBA shot charts title that we created, along with the subheader of filtering on any team and player to get their shot chart data, selecting a team, and then it gives me the initial option of Philadelphia 76ers. And then if you look through all of here, it has each individual NBA team sorted by the team name. And if we go to Timberwolves, you can go to select the player, and then it gives just Timberwolves players. It doesn't give anyone else for this case, but if you then go to a different team, then it goes to only players for this team. And let's say we want to look at a shot chart of Jimmy Butler, and there's no court now, but then once you click on him, then there's a chart that shows up along with the shot frequency, and then it has the colors associated with how often he shoots from different areas. And you can see it primarily focuses in the paint and closer around there, but if you go to someone, let's say we go to Stephen Curry on the Warriors. So if we specify here the Warriors, and then we go down to Stephen Curry, you can see that his shots are a lot more distributed just because of how good of a shooter he is. And I think this is a good project to learn more about how shot charts work and then Streamlit in general, and learning how to graph and present your data. And then if you want to actually deploy this, there's a feature on Streamlit's website where you can say deploy on Community Cloud. You can create an account and you're able to deploy your project onto their website to showcase. I think this is a pretty interesting project. Let me know what you think, if there's anything else you want covered or any questions. But thank you for watching and hope to see you in the next one.